How we doing today, guys? Split remote sensing here, and we're going to be talking about how we can use R to create an NDVI plot from a subsetted Landsat image. All right, let's get right into it. So the libraries that we're going to be using are raster, rgdal, and ggplot2. So we've commented out the install because these are already installed on our in our library, and we're just setting our variable Landsat 8 equal to a brick is just a multi-layer raster object that comes from the raster library, and this is what's going to allow us to take Landsat into R. So I will just I already have those libraries set, so I'm just going to run this one line. Run that. All right. So we have our object. I'm going to insert a chunk underneath. Now let's get some information about our variable. So let's print Landsat 8. And this is just going to give us some information about the metadata. Okay, so we have our dimensions. We have our resolution, 30 by 30. This is expected out of Landsat. The reference system, data source, and the minimum and maximum of all of our bands. We have 7 bands here. All right, so we no longer need that. Let's insert another chunk underneath. So now let's just plot and see what's up with Landsat 8. So just create a plot instance, and this should return. And it does. It returns all 7 of our plots, and we have a nice color scheme. I like it, so got lucky there. But what we want to do is first we'll create an RGB image, and that'll just allow us to visualize what the scene actually looks like. By the way, this is you'll see that this is an area in the western basin of Lake Erie. And so first we'll create an RGB. Then we'll create a false color composite, and then we'll create an NDVI image. Alright, so don't need that anymore. And if you're curious, this is the R Markdown. I prefer it to the regular R script, and just because you can run chunks similar to the Python iJupyter notebook. So let's go to plot RGB, and I always stop to read the functions, and make a red, green, blue plot based on 3 layers. So basically, stack 3 layers. All right, so we'll do plot RGB Landsat 8. All right, comma, axis are true. Oops, true. Red equals 4 for Landsat. Green equals 3. And oops. Let's be consistent. And blue equals 2. And we're also going to apply a linear stretch to the data. Stretch equals linear. And we'll give a title to it as well. Main equals bands 432. All right, everything looks good. We shouldn't have any errors here. All right, so this is the image that we're going to be working with. So we have impervious surfaces right here, City of Toledo, and then some vegetation features out here. We have a a state park right here, and a western basin of Lake Erie here. All right, so there's our RGB, and we'll compare that to a false color composite, which will be 534 instead of 432. Plot code plot RGB Landsat 8 axis are going to be true again. R is going to be equal to the near infrared band this time, and then green will be equal to red, and blue will be equal to green. And we'll apply another stretch, but this time it'll be a histogram stretch. And then the main, we'll title this bands 543. Second check. Yep, looks good there. Go ahead and run that. Looks a little bit darker than expected. Want to know why? Because I spelled stretch wrong. That looks better. Alright, so now we can see that our impervious surfaces are kind of a cayenne color. Lake Erie itself is darker blue, and vegetation features are easily distinguished. Compare that to the RGB. Very useful in distinguishing land cover types. Alright, so now that we have that visualized, let's insert another chunk of code and actually start working towards NDVI. So to do this, we're going to set two variables and then just perform some simple math on those. The equation for NDVI, I guess I'll type that out. It'd be near infrared minus red, and that is divided by near infrared plus red. And these are the wavelengths. The wavelength of near infrared minus the wavelength of red over the near infrared wavelength plus the red wavelength. So we're just going to call that. So band 4, which represents the red band, is going to be equal to raster. And this is what's going to allow us to create a raster layer object. Landsat 8, and that's the raster we're working with. And the layer that we're interested in is layer 4. Okay. Looks good. So now we'll set our near infrared band equals raster. Yep. Landsat 8. And then layer is equal to 5. Then we'll apply the band math. NDVI is equal to band 5 minus band 4 divided by band 5 plus band 4. Make sure everything looks good. Okay. Now, let's plot NDVI. Go ahead and run all that. And there we have it. This is our NDVI image, and we can see that the water features and the impervious surface features, usually they should have a neutral NDVI value that hangs somewhere around 0. And vegetation features should have a NDVI value that hangs around somewhere in between 0.5 to 1, depending on the vigor of the vegetation. And we have a nice color scheme here. I don't think there's really too much to change. Alright, so now we have our NDVI plot. Next, let's visualize the frequency of the distribution of our NDVI values. So to do that, we're just going to create a histogram. So it'll be hist, NDVI. The title, main, is equal to Landsat NDVI histogram. And then we'll give it a border as well. Border is equal to blue. Color will be equal to spring green. Yep. We're having fun here. And then we'll give it an X label. X label is equal to NDVI value. And the Y label should just stay as frequency, so we should be all right there. Go ahead and run that. And there's our histogram. So looks like we have bimodal log normal. And that's to be expected when we have a large water body that should all have values around 1. And we can see this here is dominated by the water body and the impervious surfaces. And then the rest is the vegetation, and that'll be the other bump here that we see. All right, there you have it. Thanks for listening, guys, and we'll see you next time.